I'm about to present to you a topic it's a topic I'm extremely proud to have been involved with. It was extremely challenging. It required me to push myself creatively, innovatively, and was basically consisted of day-to-day problem solving with technology that you'd normally find within a lab setting. There's only a handful of bars in the world that were really using this equipment at the time, so it you know it was a real honor to be able or be requested to come and consult on this project. The topic is the utilization of technology in the innovative cocktail design. Let's talk about first of all what the current state of the art is. You have people that use documented recipes that if they use a certain range of ingredients with certain measurements and use a certain method to mix them, they'll get tried and tested result, which is consistent every time. Then with people that use their intuition on this in these aspects and actually go ahead and create their own drinks and look at how flavors actually combine with each other and integrate and adjust measurements based on this. And then further again, you've got people that are being a wee bit more creative and using some culinary techniques such as deconstruction of drinks, using molecular mycology, using foams, gel spherification, dry ice. But exactly have I become involved with innovating this, or how did I become involved with innovating this? I know a guy called Chris Baldwin who I've worked on and off with over the last 6 years throughout my degree, and starting from a bartender and developing into managerial roles, staff training roles, and then into a more consulting type or style of role. He approached me with a concept for a bar that he was about to launch called Copper Blossom. They wanted to provide an elegant product that was innovative and was using the technology that I mentioned. They wanted to really focus on a high level of customer service and product that they were delivering, and basically deliver an offering that wasn't existent in the current market. This involved an in-house lab within the venue with the centrifuge and this really cool bit of equipment called a sonicator. So to sort of highlight the uses of this equipment and how I utilize them in this project, I'm going to look at a very classic cocktail called the Bloody Mary. You can see it here on the screen. It's very vibrant. It's very aesthetically pleasing, and it's a drink that's very personal to customers. They like it made in a certain way. People have their own variations of this drink, but in essence, it contains vodka, tomato juice, lemon, Worcester sauce, and Tabasco sauce. Now let's look at the clarified Bloody Mary that we delivered. Now you can notice straight away from this shot, it's a bit far removed from the previous classic Bloody Mary that I showed you. It in essence looks like a glass of water and was just as refreshing as one. But you can notice some aspects of the Bloody Mary there. You've got the tomato garnish, you've got the lemon, you've got the celery. But our drink really focused on shocking the customer and delivering something that they really weren't expecting, or sort of played with their perceptions. The ingredients included sonic infused vodka, clarified tomato juice, clarified hot sauce, and it had an element of customer interaction as well in the form of these pipettes that you see on the screen. These contained concentrated spice, herb, and sherry, so the customer could actually alter their drink and make it their own based on what they added to it. And there was a real drive to be sustainable within all the products that we were creating. So I'll get on to it, but during the clarification process, there's a byproduct. There's a thing called a pellet. So all the solid that you remove out of a juice, we dehydrated these a lot of the time and used them for garnishes. But in particular with the Bloody Mary, the dehydrated hot sauce and tomato pellet, we blended this with a small amount of salt and served it up as a garnish at the side, as you can see in the white dish. The customer was then able to take apart as cherry tomatoes and dip it into this and have a savory aspect added to the drink. So how was this possible? Let's look first at how the clarification process was possible for the tomato juice and the hot sauce. To do this, we are basically looking at how enzymes can increase the rate of pectin deterioration. And first of all, looking at what exactly pectin is. So pectin is found in all plants and fruits, and it's what basically holds cells together. It's a complex polysaccharide. It's closely related to starch. In the presence of high volumes of sugar and acid, it will actually gel. You'll notice this being used in jams. And it's actually what suspends particles in juice when it has a cloudy appearance, such as cloudy apple. We can actually see the natural breakdown of pectin in this slide. So this is pear juice that I'm working with in the current place that I work. And you can notice that molecules have settled to the bottom and also rise to the top. Now this is the enzymes that are naturally occurring within the fruits that are causing this. And what happens is they cause this to separate, and in doing so, they're basically breaking down the pectin that encapsulates proteins within the juice. Now these proteins are positively charged, and the pectin encapsulating it are negatively charged. So all these molecules basically repel each other initially and cause this haze, but as the enzyme breaks down this pectin capsule, it exposes the positive charged proteins within. So just like magnets attract each other and repel each other, they're initially repelling and suspending in air, and as this positive protein is exposed, they attract each other and they form what's known as flocks. And as these increase in size, they settle to the bottom or float to the top, dependent on their actual density. So there is actually optimum time or temperature ranges for this, but the actual temperature range at which enzymes are active and falls between 5 and 50 or 58 degrees Celsius. And the standard sort of the common rate of deterioration and clarification, the time scale for this natural settlement under the force of gravity is anywhere between 24 hours to 72 hours, depending on the pectin levels, the temperature, the amount of enzyme that's within the product. Now, why we wanted to really utilize this and what we were doing was actually creating the perfect environment for what's known as clarification. Our concept for this was to basically source an enzyme, add it to the fruit, disperse it, and activate it at the right temperature, allow it to degrade the pectin over a given period, and then clarify. And we were basically doing this using a high-speed blender known as a Thermomix, and utilizing the natural friction developed by the rotors to achieve this temperature climb, and also to disperse it uniformly without the juice. So why might we want to clarify? Aesthetics is one of the main reasons you want to do this. If you're ever in a bar, you'll notice that the beer most of the time is nice and transparent. It's got a nice clarity, and this is because customers want to drink a nice, crisp, clean pint. And the same with wine, they want to drink a nice, clean wine that has good clarity. However, there are some beers now that are branding themselves to have a haze or they're cloudy, and this is a sort of new line of product that's coming on the market and becoming trendy, and it actually carries a much more complex flavor profile as a result. But let's look at other reasons why you might want to clarify. You've got molecule separation, which is utilized in blood works when people are taking blood samples and want to analyze how the human condition is from the sample. They will want to separate the white blood cells from the red blood cells from the actual plasma, and they do this by taking advantage of the different densities of these cells and actually allowing them to separate out and clarify. And you've got it also in molecule removal. So if you want to create plant cultures, you might want to remove a certain molecule or a certain cell from a plant culture, and you can do this by allowing the different densities of cells to separate under clarification and under the force of gravity. Now, we basically wanted to utilize a centrifuge to accelerate this clarification rate. So this was basically utilizing the principles of centrifugal force. So if you imagine an astronaut as he's undergoing training, he is inside a housing unit that's on the end of quite a long arm, and it's rotated in a circular motion. and as it's rotating in this motion, the housing unit actually wants to shoot off in a tangential direction from the circular motion. Now what's holding it in place is actually this radial arm, and there's actually a force being transmitted down this arm to hold the housing unit in a circular path. This force is actually the centrifugal force, and it's related to the mass of the housing unit, the velocity that it's rotating at, and also the distance from the housing unit to the rotational point. Now, how we utilized this was actually by sourcing a high capacity centrifuge that had rotation per minute of 4,320. So this is roughly 72 times per second. And due to the mass of the rotor, this was able to exert a force of 4,800 times the force of gravity on the buckets that we were able to insert within it. It had a 3-liter capacity also, so we could do high volume clarification, and we were actually able to reduce this clarification period down to 8 minutes, or with a maximum of 15 minutes required for elements that had slightly larger molecules. So these are actually some of the trials that we went through at the beginning. Now this was a day-to-day difficult experience. It was problem solving on a day-to-day basis, where you would set up the clarification process, you would dose the juice with enzymes, you would activate a certain temperature, and then put it in the centrifuge at certain rates. So we basically had to refine this on a daily basis. So it was just a process of going in, using a set of parameters, noting down the effects on the juice or the clarification as a result of these parameters, and then adjusting them and refining this process. So the first trial was terrible. It had terrible clarity. We had to do a wee bit of further research into the actual temperatures and length of time within the centrifuge to know how the centrifuge actually worked in the clarification process. And as the trials went on, we increased or played about with the rotational centrifugal force, increased the enzyme dose, increased the time, and time increased the clarity. But our final product had a defined rotational centrifugal force, defined enzyme dose, defined time, and we had a complete clarity in the final product. Now we did have some difficulties with the clarification, as I sort of briefly touched on there with the different enzymes. So we basically had to research and test all the available enzymes that we had out there, and they all have different properties. And then of course I discussed the refinement of dose, the activation temperature, and the time of exposure within the fruit. And we actually had to go as far as sourcing the enzyme from Sweden, the one that we found optimum. Other difficulties involved the consistency. So it was very important that we could create a methodology that was that allowed staff and ourselves to provide a repeatable product. So those are a refinement of the methodology that was sort of fail-safe, and then training the staff to actually understand these fundamentals and why the methodology was how it was. Now there was another effect on the consistency, that's the seasonality variation of pectin, and the effect that has on then having to adjust your enzyme dosing or your centrifugal time or force used. Another difficulty was quality, basically creating a very delicate and volatile product that oxidates a lot quicker than most juices. So the logistics of actually storing this and how we did that was a difficulty that we overcame. You know, it was basically came down to storing stuff at a lower temperature. So things that basically affected the oxidation rate, temperature, exposure to oxygen. So we actually vacuum sealed products, and we actually used ascorbic acid. So vitamin C actually helps reduce oxidation as well. Now this was the clarified tomato with the methods, so it's a lot much more refined, and in terms of the enzyme, the time in the thermomix, the time in the centrifuge, and actually it details how we actually stored it as well, and what we'd done with the pellet afterwards. So this is a sustainable aspect. We dehydrated the pellet and used it in the hot sauce salt. Now this sonic horn that I discussed briefly at the very beginning, so what is it? It looks pretty cool. It is actually really cool. It's really interesting bit of equipment, and what it does is it basically agitates liquid molecules using sonic waves. And what's happening here is it generates alternating pressure waves. So, and these waves are basically refracting, so stretching, and then compressing, so getting smaller. And as it refracts, millions of tiny bubbles come into formation. And then as these waves keep refracting and compressing, the bubble expands and contracts in size in a stable way initially, but eventually becomes unstable and explodes or implodes. And there's actually a huge, a very large local energy released on this explosion. Now, this actual image here describes it quite well. So you can see as it compresses, the changing bubble size gets smaller. As it refracts, it gets bigger, and this fluctuates. And then as time goes on, it becomes unstable, as I said, and explodes. Now, there's applications of this throughout loads of different industries. You see it in nanotechnology, where it's used for the homogeneous distribution of nanoparticles within a liquid. It's used in sonic cleaning within a water bath of diamonds, lab equipment. It's used in biology, and where it can be utilized to actually pinpoint these cavitational bubbles to extract fragments of DNA without actually causing any damage to the cell. And it's used in the culinary arts too, for efficient emulsification, and there are also research into rapid oak aging as well. So this volatile environment can be exploited to infuse aromatics into liquids, and this is what basically wanted to do. And I had no previous understanding of this cavitational effect in engineering, because it's quite aggressive, and it's a phenomenon that occurs in pipe bends, and actually is very destructive and erodes pipe bends. And it occurs in turbines as well. So the actual rotor in a turbine, their cavitation can occur as this is rotating around and cause very serious damage. So what we wanted to do was actually utilize this and strip aromatic compounds of aromatics such as citrus, herbs, and spices, and create and develop products such as the basil vodka, spice vodka, pink grapefruit gin, perfumes as well we were creating as well. So there's a couple of really cool applications. And the normal way that you would create things like this is to there's a couple of ways. You can make a consomme to get flavors out of fruits and aromatics, but this is sort of stewing a liquid, so it's not as fresh a flavor. And you can also do a cold maceration, where you actually macerate the aromatics in a liquid. But this takes anywhere between a couple of days to a couple of weeks. And the aromatics that you're drawing out of these compounds are they're basically essential oils, so they've got their own molecular structure, and over time these can actually fall out of your product at the end. So there's a number of benefits that we noticed with using the sonic or the sonic infuser or the sonicator, and this was that it was a low temperature rapid infusion. We had infusion times of 3 to 15 minutes, and we were able to develop a product with a fresh flavor that had a long shelf life, and actually was a homogenized product. So the oil was homogenized into the spirit. The fusel oils were actually homogenized into the spirit and didn't fall out of structure. So this is actually the sonic prep or the sonicator in use, and you can see the bubbles generating here, forming, collapsing, and basically stripping the fusel oils off the mint. You can see the jet initially, and then the whole liquids coming under cavitation. So this was an experiment to develop a rum that tasted of mint, so we could use it basically in a mojito and have a mojito that had no mint that was visible to the naked eye. But as you drank it, you got this really refreshing taste of mint. So again, to sort of shock the customer or give them that element of, you know, awe or bewilderment. So again, there's difficulties with the sonication process. Similar with the clarification, consistency was a difficulty that was encountered. So development of, again, a set of guidelines and methodology and training the staff to understand these. But one other difficulty that was encountered, and you would have seen it in that video actually, was uniform distribution of the cavitation. Now it's important that all aromatics material within the liquid was being affected in a uniform manner, and not one particular piece of aromatic was getting over degraded, as this would lead to um, a less integrated taste and some undesirable tastes as a result. Aromatic robustness, started touching on this undesirable taste or aroma. Mint and basil in particular aren't so robust, and when they are degraded, they can impart undesirable smells and tastes, sort of like a damp smell. So sourcing a more robust varietal was a difficulty that we came across, and seasonal variation also affected this robustness. So these were things you had to be aware of. Now, quality, again, as we discussed with the clarification process, it was important that we were able to repeat this process consistently and create consistently high quality products. So oxidation, again, was one of the key factors, and reducing this in a very similar way to how we reduced the oxidation effects for the clarification products. Now, this is the ingredients and the methodology for the Bloody Mary, which was refined. We were using thyme, finger chilies, and lemongrass as the aromatics for this, and again dehydrating the ingredients afterwards for a more sustainable use of the product. So just to finish on this presentation, I'd like to look at, for me, what were the challenges, the highlights and the rewards. Now, I mentioned briefly at the beginning the challenges. Using this type of equipment, there, as I mentioned, there's a handful maybe of bars that use it. There's no best practice, there's no guidelines, there's no recipes. So the biggest challenge was actually spending that 2 to 3 months initially trying to figure the whole thing out and make sure that it was consistent. So this is a day-to-day problem solving, and development of the methodologies and training the staff to ensure repeatability, and the logistical difficulties for operational logistics, again, was a huge challenge. But we built and were successful in it, and this again was one of the highlights as a result, being our delivering a successful project at such a high quality. Developing drinks, which is sort of just touched on there previously, but developing drinks that you're not going to get anywhere else in the world, developing techniques that nobody else is using, and I've not seen anybody really create some of these products since. And obviously achieving global brand awareness was a huge highlight, so having different companies give us bespoke access to some of their products, and having global brands such as Grey Goose, Bacardi, Kettle One, Full Trace, you know, the list goes on of guys that sort of wanted to work with us because of how sort of industry leading these techniques and methodologies were. And finally, let's touch on the rewards. And the reason why I wanted to really discuss this project was because of how rewarding it was for me. It pushed me creatively, innovatively, put me really outside of my comfort zone in terms of my skill set and being able to problem solve in an area with no prior background. Alongside this, and equally as rewarding, was actually working with the staff that got involved with us. So people that work in hospitality, and this is their career. We had such a high influx of staff that came to work for us just because we had this equipment. They didn't have any access to this anywhere else in the world. So providing people with this sort of experience is very rewarding, and empowering them with the knowledge and imparting that knowledge that I had learned over the development stage and the research stage, and actually being tested by them. They sort of further push myself and understand the concepts a bit better, and look at other applications for it. And finally, working in the team that we had throughout this period, it was highly diverse, highly creative, and it was an extremely team-led environment, and these environments are extremely rewarding. So the perspectives that you get or receive or are exposed to within these environments are great. So I'd like to finish on that note. Thank you.